Greetings and welcome, friends. Mr. Waddy here in my Alg1. We were graphing absolute value graphs yesterday, and it was amazing. It was absolutely amazing. Yeah, that was that. So here's question 6 from last night's quest. It says graph the function and compare the graph to the graph of f of x equals abs x. So first of all, the graph f of x equals abs x. Let's graph that first. We'll do it so like this. It has a vertex at 0, 0. You guys all remember this, right? So vertex at 0, 0, and it makes this V shape, which is actually kind of easy to remember because it's like absolute value, V value. Yep, so here's the regular graph. It's got kind of two different slopes going on here. Right, up 1 over 1, up 1 over 1. But also on this side, it's down 1 over 1, down 1 over 1. So we had the vertex. All right, vertex. It has its own slope, right? Up 1 over 1, up 1 over 1, but also backwards 1. And it also had this thing called the axis of symmetry, in which if you imagine folding this paper along this dashed line, that the graph would map onto itself. I can also use that to my advantage. If I graph the right-hand side, I could then realize, hey, this point is 3 units away from my axis, my mirror line, and so 3 units away over here is going to be another point, right? Here's 5 units away from the mirror line, so 5 units away over here is another point, right? So this was the axis of symmetry there. Symmetry. All right. And so here I want to graph r of x is equal to abs x plus 5. And so that plus 5, notice, is on the outside. It's being added. Because it's on the outside, it's going to be a vertical shift. And which way am I moving this? Up 5, right? So that's what is happening as a result of that addition. Let's see, what? Nope. It's not changing the slope. It's just changing every point up 5. Let's see. I already used orange. I'll use orange again. That's fine. Orange. So this point, the vertex, is up 1. This point is up 1. This point is up 1. Every point on the blue graph is being shifted up 1. Oh, thank you. With the save, let me make sure I get you some points in the old class craft. Let's see. Fixed a mistake. Man, with the save, making my video better. Much appreciated. So yeah, so everything is being shifted up 5. Thank you. Even better. All right, so up 5, up 5, up 5, up 5. Even over here, this one's going up 5. All right, everybody up 5. All right, so let's graph my new function. So the vertex is up 5. All the points are up 5. It's all the points. Pretty good. And so it's still exactly the same shape. It's just been shifted up 5. Here they asked a question. Describe the domain and range. So the domain, notice if I was to smush the purple graph down to the x-axis, it keeps going forever this way, by the way, it would cover everything, right? Everything. So you could say the domain is all real numbers. All right. If I want to talk about the range, remember that's if I was to smush it to the y-axis. And notice I don't have any points all in this area. Do you guys agree? That the purple graph only exists for values that are bigger than or equal to 5. The blue graph was 0 or more. So I'm going to say the range is the set of all y such that you could say y is greater than or equal to 5. No, that means negatives, positives, fractions, decimals, irrationals. All the numbers that you know of, all the real ones. It doesn't include the fake ones. I can't tell you that. In algebra 2, you'll learn about the non-real numbers. Okay, so guys, next question. Here we go. All right, same idea. Let's. I'm gonna speed up. I've explained a lot in that last one.
So it's on the inside.
All right. Let's see. A smoosh?
No.
A stretch? No. So here's the parent function. Inside means it's going to be horizontal. I'm not multiplying, I'm adding, okay? So it's going to be a shift.
Right. Shift right.
To the left.
Right.
Left. Because you said when it's
For horizontal, it's the opposite of what you would expect. So it's going to be left 1. Okay? So every point on this, it's going in the opposite direction that you'd expect. Right? +1, but I'm moving in the -1 direction. So all of these get shifted over. This gets shifted over. Everybody, infinitely many points are being shifted over right now. Yeah, just 1 over, right? Because that was a +1. And so my new graph, my purple graph, it's very similar. Same size and shape. It's just been shifted over, right? Let's see. Those of you guys on your Chromebooks, just make sure you're layering here. So shifted over. What is my new vertex? That's a question they didn't ask here. What's my new vertex? What are the coordinates of my vertex? For the 0, 0. -1, 0. So there's my new vertex, right? Cool. My domain is all real numbers. Right? Everything that way. And how about my range if I smush it to the y-axis? It doesn't exist below here. So domain, I guess I'll write it in blue. All real numbers. And the range, what do you guys think the range is? Everything above. Now, it wasn't shifted up or down, so it's everything above 0 or equal to 0. So the set of all y such that y is greater than or equal to 0. Your book might write that a little bit different, but it's the same idea. Everything bigger than or equal to 0. All right, last problem that I'm going to do for this video. All right, he's telling me already. This is on the outside of the abs val, so it's vertical. And I'm not adding or subtracting, I'm multiplying. So it's going to be a stretch or smoosh. And this is bigger than 1. So it's a stretch by 3, or a stretch by a factor of 3. It's 3 times as high. You could think about it that way. All right, let's giraffe the parent function. Speedy, Mr. Waddy. Here we go with the giraffe. Doesn't matter. It's close enough. So what is 0 times 3? 0 times 3 is 0. What is 1 times 3? 3. What is 2 times 3? 3 times 3 is 9. And that's off my graph. And -1, or sorry, no. -1 is the x coordinate. I'm looking at y. It's a vertical stretch. So, no. It was +1. I put the negative in your mind. I'm sorry. So this was 1 high. 1 times 3 is 3. This was 2 high. 2 times 3 is 6. 3 times 3 is 9. All right, so the whole graph, you can see, it's the same vertex. and the entire graph has been vertically stretched. Oh dear, what have I done? Verticalish. There we go. So that's what that looks like. Domain stays the same, range stays the same, vertex stays the same, but clearly the shape of this graph has changed. All right, have a good day, internet friends. I'm out of here.